Section 3.5 is on inference for a single proportion. The first learning objective is to describe the sampling distribution of the sample proportion, including shape, center, and variation. So let's first talk about those three characteristics of the sampling distribution. The shape of the sampling distribution of p hat, which is the sample proportion, is approximately normal. So we have that bell-shaped curve if n times p is at least 10 and n times 1 minus p is at least 10. So these two conditions tell us that our sample size is large enough relative to the population proportion for the distribution to be bell-shaped. Next, we'll talk about center. We're going to use the notation mu with the subscript p hat to indicate the mean of the sampling distribution of p hat. That is equal to the population proportion, which is the symbol p. So the sampling distribution of p hat is centered around the population proportion. And then the variability. We'll use the symbol SE, which stands for the standard error, the subscript p hat, and the formula for this is p times 1 minus p over n, and then you take the square root of that whole thing. So here's an example. According to the Congressional Research Service, 64.9% of Utah is federal land owned by the federal government. 100 locations in Utah will be randomly selected and checked to see whether they are federally owned. Describe the sampling distribution of p hat, the proportion of locations that are federal land, for samples of size 100. So we're going to include center, variability, and shape. So the center is equal to the population proportion, which is 0.649. So this is equal to p. P was given to us as the 64.9%, and if we write that as a proportion, it's 0.649. Next, we'll talk about the variability. The standard error of p hat is equal to, and you can do this in GeoGebra or in any calculator. I've just pulled up a calculator here to show it this time. So I've got 0.649 times 1 minus 0.649 divided by our sample size, which is 100. I'm just using that square root of p times 1 minus p over n formula, and that gives me 0.0477. So if I round that, I get 0.048. That is my variability. And I'll add the formula here as well. This is equal to the square root of, make that a little bit bigger, 0.649 times 1 minus 0.649 divided by 100. And now the shape. In order to check the shape, we're going to do n times p, so our n is 100, times our p was 0.649. That equals 64.9, that's above 10. And we're also going to do our n times 1 minus p, so 1 minus 0.649. And that gives us 35.1, which is also plenty big. So since both 35.1 and 64.9 are above 10, the shape of our sampling distribution of p hat is approximately normal. Let's do one more example. According to Business Insider, 55% of Americans use Netflix to watch television shows and movies. Describe the sampling distribution of p hat, the sample proportion of Americans who use Netflix, for samples of size 64. Include center, spread, and shape. So again, the center is equal to our p, which in this case is 0.55. The standard error of our sampling distribution of p hat is equal to the square root of 0.55 times 1 minus 0.55 divided by our sample size, which here is 64. So we get 0.062. And then to check our shape, we need to do 64 times 0.55. There's our n times p, which is 35.2. That's big enough because it just needs to be above 10. And then we're going to do 64 times 1 minus 0.55. And we get 28.8, which is also above 10. And so therefore our shape of our sampling distribution is approximately normal. So center is equal to p, which is 0.55. Variability is the standard error of p hat, which is equal to the square root of p times 1 minus p over n, which is 0.062. You can see the calculation up here on the calculator. And our shape is approximately normal since both n times p, 64 times 0.55, and n times 1 minus p, 64 times 1 minus 0.55, are both at least 10.